This video is going to talk about creating backend systems for Thorium. I'm going to talk about the file structure a little bit and also talk about the process that I follow when I'm creating a new backend system. In our case, today we're going to be creating the docking ports and the shuttle-based system, which allows ships to dock with the simulator. First thing I want to do is kind of go over the file structure of Thorium a little bit. Here I have my code editor open, and there are a couple of files that are here in the base that you should be aware of. The first is the server. This is the thing that loads everything else and is the entry point. It starts up a couple of HTTP servers, one for GraphQL, one for the subscriptions, and you can see all of the stuff that it's pulling from the other files in order to take care of getting all that loaded. In the app.js folder, it has all of the data for the entire simulator, for everything actually, is inside of this file, and it stores it just in an array on this object called, in this case it's events, but we import it from the app.js folder. And then it has a couple of helper methods for handling events and whatnot. And everything else is inside of this server folder. So we've got our GraphQL schema with the types, subscriptions, queries, and mutations here. We have the resolvers for GraphQL listed here. We have the recurring processes, which run on timers. For example, the reactor heat and decreasing the power levels of the batteries happens in the reactor.js file. We have a couple of helpers that just take care of certain things. All of the events are here. And then we have the classes where we actually define the logic of the individual components of the simulator. So before we do any coding, I'm going to jump up to the whiteboard and map out what these systems are going to do. So the first thing I want to do when I'm developing a new system for Thorium is I want to sketch out kind of how it's going to work. In this case, since we're working on docking and shuttles, I'm going to have to keep track of a little bit of information. One of them is the shuttle bays, because a ship can have multiple shuttle bays. And since shuttle bays and docking ports are basically the same thing, I'll have to consider them together. Shuttle bays and docking ports are going to have a couple of properties on them. They're going to have if the clamps are attached, if the ramps are extended, and docking ports only have clamps and ramps. Shuttle bays can have doors as well, so we'll have to consider that. And maybe some way of differentiating between the two, or perhaps we just have it so that shuttle bays and docking ports both have clamps, ramps, and doors. But on the front end, the docking ports don't worry about the doors at all. That's an option. Secondly, shuttle bays and docking ports can have a ship inside of them. And we'll keep it simple for now, since all that a ship really needs is whether it exists or not. So if it's docked or not. And then another thing that we need to consider is some kind of visualization of whatever it is that's docked. So a picture of the ship, a little image, some other way of identifying the ship easily from the view. We'll probably also want to have some kind of identification, both an ID number for internally in the system and some kind of label or name. And since we're going to be having different cards for shuttle bays and docking ports, we probably won't want to have some kind of type to differentiate between if it's a shuttle bay or a docking port. So that way, one screen is only going to show the shuttle bays and one screen is only going to show the docking ports. That's basically all that we need for this backend system. So now we can start creating the GraphQL schema for the system and take the information that we have here and write it out in GraphQL so that the data can be transferred. Once we get done with that, we'll create a class to define the logic of the shuttle bays and docking ports, and we'll move from there. Now that we have everything mapped out, I can come here to my code and we're going to create a couple new files in the schema folder. I find it easiest to create the GraphQL schema first before doing anything else, because it allows me to have a framework to wrap everything around to make sense of things. So we'll start by creating the type. And this type is going to be based off of the information that we wrote down on the whiteboard. So I'm going to create a new file. I'm going to call this file docking. That pretty well encapsulates how it works, because it's both docking ports on the outside of the ship, which other ships can dock onto, and shuttle bays, which is inside of the ship. They operate basically the same. You'll notice in every single one of these schema files, all that I'm doing is just exporting a string. That's the way that GraphQL schemas work. They're just strings. So here in docking, I can start with export default. I'm going to use the backtick so that I can write it on multiple lines without concatenation. And I'm going to start by creating a type for the docking port. We'll just call it a docking port. It'll work the same for docking ports or shuttles. Every individual entity has to have some kind of identifier, so we'll call this an ID. And in GraphQL, you have to specify the type, so we'll call this a type ID. Let's see, we also need to have a label, which is a string, and a type. In this case, this is the difference between a shuttle bay and a docking port. And I suppose you could extend this to be multiple types in the future, such as in the old Magellan, it had runabout pads from Deep Space Nine. Anyway, I'm not going to worry about that right now, but for this I actually want to create a special GraphQL type called an enum, and I'll call this docking types. And here I just type in the strings that are the different types that this possibly can be. In our case, we want it to be shuttle bay and docking port, and I'll just leave that as lowercase strings. Here I'm going to use this enum for the value of type, so it can only be those two things. And then the three different values of whether the clamps are attached, the ramps and the doors. In our case, let me check something really quick. If I go to ship structure, we already have that. Nope, that's not it. Maybe on the simulator? Oh, it's on the ship. The ship already has clamps, ramps, and airlock, but it also has this extra stuff. So I'm going to duplicate this a little bit. So clamps is a Boolean, ramps is a Boolean, and doors is a Boolean. Okay, so that takes care of that. Oh, and we also need to have information about the ship itself. Since in most cases, there can only be one ship attached to a docking port at any given time. So in order to simplify things, we'll just say that we'll just have the information attached to the docking port itself. We'll have the image, which will be a string. This is going to be a reference to an asset. So we'll just call it a string here. And then we'll also have docked, which will be Boolean. One thing which I forgot, and you'll find that this will happen a lot, when you visualize it and write it out, sketch it out the first time, you might miss a couple of things which you have to put in later on. So I realize, oh, no, just kidding. I thought that I would have to have something for if the ship was present in the docking port, and another thing for if it was actually docked with the ship. But I realized that doors, ramps, and clamps is basically the same thing. Okay, so there's that. We need to create one more thing here. in GraphQL, you have to specify an input type for any arguments that are any objects that you use as arguments. In this case, I want to use a docking port as an argument. It'll clean things up in our GraphQL queries later on. So I'll say input docking port input, because it has to be named something different than that. And I'm just going to put the exact same information in here. If I was using special types here, like for example, if I were to say that the image is actually an asset type, I couldn't necessarily use that as an input because the asset type probably isn't an input either. So you want to make sure that if you're creating an input, that all of the subtypes that you use also are viable inputs, either scalars like we have here with the booleans, strings and whatnot, or they're an input that's been defined. Okay, so that's all we need to do with this file. However, we do need to reference it in another file, and that's the index.js. Unfortunately, it doesn't automatically detect all of the GraphQL that we write in all of these files. I have to specifically put it here. Conveniently enough, though, I can just export it directly. So I'll export docking from /docking, and that's all that has to be done. It's now going to detect that GraphQL type. And we can double check and make sure it works by going to the Thorium project and running npm start. And if the server starts up okay, oh, it crashed. Yep, there you go. Yeah, so that means something's wrong here. It says type docking type not found in document. So somewhere here, oh, it's because I didn't put the S on the end there. So it's going to catch my errors in the schema, and it's still having issues. Oh, it's because I didn't put it here as well. So in the docking port input and the docking port. Now if I come back, loaded just fine. Perfect. So now that we have our type written, I can do one of two things. I can either start writing my mutations, queries, and subscriptions in GraphQL, or I can take what I've written for the type and I can translate that into fields in a class. I think I'm going to do that first. I'll write the mutations, queries, and subscriptions later, and I'll write the class now. So I'm going to come here to my classes. I'll create a new file, and we're going to call this docking. And if I want, so the question we have to ask here is, how do we want this to work? Do we want there to be multiple docking ports attached to a simulator? Or do we want to have docking ports be more like a system? So we have a single docking port system, and that has a list of docking ports inside of it. I think in our case, we want to have multiple docking ports attached to a simulator. So I'm going to create a class that is just a one-to-one direct connection from this to that. Just for ease of use, I'm going to copy some of the code that I have here on my engine, just to simplify things a little bit. Paste that in. We'll get rid of the heat mixin because docking ports don't have heat, but I'm going to use the system mixin, and here's why. If we take a look at where it's coming from here in the generic file, and we go to system, it has a lot of useful things here. Stuff actually that I can use in my docking port itself. It has the simulator ID, it has the name, display name, which is separate, power and damage. Docking ports really don't need power, but it would be kind of cool if you could damage individual docking ports. So maybe I will treat this like a system, but maybe you'll have multiple docking ports on a ship. I don't know, we'll figure it out. Maybe I'll have it be something separate. As you can see, I'm still figuring this out as I go, which is perfectly fine. So with this though, since I'm going to be extending system, I need to change my type over here. So instead of label, I'll have name, and that needs to change as well. And I'm not going to worry about changing anything else, although I do need to include simulator ID as an ID in both of these. so that I can reference it by simulator ID as well. Okay. And then I'm not going to include power, but I am going to include damage. And here I'll just say this is a Boolean for whether or not it's, well, actually I'll make that separate. We're not going to worry about damage in the input. Here though, I need to duplicate the system a bit. In my interface I have damage as a damage type. And so I'm going to want to include that here so that I can actually see it and use it, manipulate it. Okay, awesome. So far so good. Since I'm extending that, I'm going to write in all of the necessary information that we need. So I'm going to create a constructor. And I'm going to have it fill in all of the params. Now we have to remember the params are going to be filled in two ways. One of them is when it is created for the first time. In that case, we'll want to have default values that we put in if there's no regular values being put in. The second time is if the system is being loaded. If Thorium is shut down and it starts back up, it loads it from the storage and creates the new object. We need to be able to create it that way. ID, simulator, and name are taken care of by the system object class that we're extending from. So I need to start with type. And I'll say this dot type equals params dot type, or, and I'll just default to shuttle bay. Let me make sure that that's correct. Yep. So it'll default to being a shuttle bay, which is fine. Oh, excuse me, I need two super params so that this class actually gets constructed. So then this dot clamps equals params dot clamps or false. So by default, there's nothing there. Although we might want to make it so by default there is something there. That would make a lot more sense. In some cases, in fact, what probably needs to happen is if there is a shuttle there, then it needs to, rather if the type is a shuttle bay, then it needs to default to having a shuttle inside of it. But if it is a docking port, then it needs to default to not having it. So I'm going to do a little bit of logic here. Say if this dot type equals shuttle bay, and we'll initialize it differently there. So we'll say this is true, and then else, and I'm going to copy and paste it in a second. So this dot ramps equals params dot ramps or false, or true, excuse me. And this dot doors equals params dot doors or true. So that's if the ramps are attached, the clamps are attached, the ramps are extended, and the doors are closed, which means the shuttle is safely secure inside of the shuttle bay. Okay, and then we also need to take care of the image equals params dot image or default. We'll capitalize it, and actually, since the image is going to be an asset, we're going to want to put this into an asset string. So they start with slashes, and we'll call this asset string docking images, and then we'll just have a default that we'll upload eventually, not today, or not right now. And then this dot docked equals params dot docked or true, because there is something there. And then this dot, and then damage is taken care of by the shuttle, or by the system class, so we're good. So now I'll copy this and I'll invert all of these to be false. We'll keep it so that it has a default image, which will work just fine. It's not going to cause any problems. Okay, now that we have that taken care of, we need to create some methods on this class to modify everything. Now, since we have this docking port input, makes it a lot easier to modify things all at once. So all that I have to do is just say update docking port with all of the things that I want to be able to update at once. So I'll say name. We'll make it so that you can update the type. Clamps, ramps, doors, image, docked. And then I'm going to do just a fancy little thing here with all of these. Oh, that's not right. I want to do that. So we've got all of those, and I'm going to select all of these. And actually, I'll select them like this. Wrap them up and say if that is true. And then I need to select all of this again. Then this dot the thing equals the thing. Perfect. So that makes it so that I can selectively update individual things on the docking port just by changing what stuff I put inside of my docking port input. So that way I only have one mutation. It simplifies things substantially. There are a couple of things I need to watch out for. For example, if I have a blank string in the name, it's not going to update properly. And so I need to put or name equals blank string. Clamps, ramps, doors, in fact, all of these, I'm going to have to add something where I say or this thing, clamps, ramps, doors, docked, or this thing equals false. So if it's null, don't do anything, but if it's false, then update it. Image we don't have to worry about because that's always going to be taken care of by a select dropdown, which simplifies things also, and then type is going to be the same way. Okay, awesome. That's pretty much all we need to do there. So now that we have that in place, we should be able to create our queries and our mutations. So let's come back down here to our schema, and I'm going to create a new file in the query. We'll call this docking.js. This is the same as with the type, except I'm just going to say the name of the query. This is docking, and it's going to have a couple of parameters. We'll probably want to get docking stuff by ID, so I'll say ID, and you have to specify the, you have to specify the parameter and the type of the parameter. I also want the simulator ID. I'll say that's an ID. And we're also going to want to query it by the type. And the type is going to be a docking types. So that way on the one screen we can query just the shuttle bays, on the other screen we can query just the docking ports. I can't think of anything else that we would want to have here. So I'm going to say that it's going to give us an array of docking port. So multiple docking ports, and that's all that we need for that. I'm going to come down here, and I copied that because the subscription is going to be very similar. The way that I'm writing these subscriptions for the most part is they're basically duplicates of the queries. They return effectively the same information. So export default, and then I'll put docking there. The one difference is we need to make sure that we change this so that it has a different name from the query. So I just say docking update. And it has the same parameters and it returns the same data. In some cases, I do it a little bit differently. For example, on the messages, I do have a message updates, which is basically the same as the query, but I also have send message, which only returns one single message for simplifying sending of messages. Here, it's okay for us to update it wholesale because there's not going to be a whole lot of data. Yeah, so that's the subscription. And then finally the mutation. This is docking.js. Since these aren't systems per se, docking, we're doing it differently from a system, but it still is like a system. It needs to be damaged. It needs to have some other system-y type things taken care of. In fact, that is something, well, no, I'm not going to worry about that. We're going to want to make sure that we include those in our mutations. So let's create our mutations really quick. The first mutation is very simple. It's just update docking port. And here, all that it's going to do is just take a docking port input, because this input has all the information that it needs in order to update, including the simulator ID and the type and the ID and whatnot. So I'm going to put a bang at the end of that. That means this is required. You have to specify a port if you're going to update the docking port. And it's going to return a string. That's because with Thorium, our mutations never return anything. All of the updates happen through subscriptions. So we just return a string, and that means that it's going to return null, which is fine. We also want to update docking port damage. So I'll say port equals docking. Actually, the port is going to be an ID because we're updating an individual docking port. So we'll say ID is an ID, and we'll say, let me see how the damage is done elsewhere. If we go to our systems mutations, we've got a damage system, damage report, repair system, and then request damage report. Oh shoot. You know, what I might do is make it so that I use the same mutations here. So we'll still say damage system, even if it is referring to a docking port, just because it's basically the same logic. It means I don't have to duplicate mutations, don't have to duplicate logic, and it works in effectively the same way. I'll make it so it checks to see if there's a system, and then if there is no system, it'll check to see if there's a docking port that can be damaged. So that simplifies that. So I'll just get rid of that. I only need the one mutation, and it's just going to update the docking port. Okay. So now that we've created those files, we need to link those in with our index.js. So I'll come in here, say export docking from /docking. And the great thing is, since my files are named the same thing, I can do that for mutations and for queries and for subscriptions. And it's all just right there. Come back here, and it started just fine, which means there's no problem in my schema. Okay, so we're basically done writing schema. I can't think of anything else we need. Maybe we'll come up with something later. The next thing that I do is I create a resolver. So here's my resolvers folder, and I actually have a template here for the resolver. So I'll open this up, or I'll copy this rather, and come up here, paste it, and it creates my template. So I'll rename this and call it docking.js. It gives me a template queries, template mutations, and template subscriptions. Really simple. I could probably make it a little bit more elaborate later on, but for right now it's fine. I'm going to rename that to docking. And in our case, we're going to need to have access to app. So I'll just copy this from the crew and paste it in so I have access to app. The reason why is because we use app to trigger the mutations and also to get information from the data store for the queries and the subscriptions. So let's start with our query. If I come back here to my query, not that one, not that one, and not that one, but this one. It's just called docking, and it takes ID, simulator ID, and type. We don't need to worry about that right now for the resolver. I just have to put this in as a property of docking queries, and it takes 3 properties. One of them is the root value, one of them is the args, and I suppose I actually do need that for the queries. So it takes ID, simulator ID, and type. ID, simulator ID, and type. And it also gets context. I'm not going to worry about that for the queries. So now I need to access the data store and pull out the docking queries that match these parameters, if those parameters exist. The thing about it is I don't actually have a store for the docking ports yet. I have app here, but I haven't specified where I'm going to put them. So I'm going to come back here to the app.js file. Here's all of the different arrays of stuff that I can use. And I'm going to create a new one for the docking ports. So this.docking ports equals array. Awesome. And just double checking to make sure I see if I need to do anything else. Oh, there is one thing. Let's go back to our class really quick. One thing that I didn't do, that I do need to do, is specify the name of the class as a property of the class. So here, I didn't name it, I didn't rename it, so it's still called engine. So I need to call this docking. And here, what I'll do, or I'll call this docking port. This dot class equals docking port. The reason why we have to do this is because when Thorium is recreating itself from the JSON data store, it doesn't know what class each individual object was because it got converted to JSON. So to make sure the objects still work, I have to specify the class here so it can go in and reload the data as the individual class that each thing is. So that's all that I have to do there. And then I have my docking ports there. So now I can pull the information out of the docking ports. So let's come here and we've got our docking and I want to get the docking ports. So let docking ports equal app.docking ports. Awesome. That's all I need to do there. And then I can return docking ports and that will return the list of all the docking ports that are in the app. Now, I don't want to necessarily do that all the time. I want to be able to filter it by simulator ID and type. And I also want to filter it by ID. Now, I know if I'm filtering it by ID that there's only going to be one. So I'm just going to do this from the get-go and say if ID, then return docking ports.filter. Now, I'm using .filter instead of .find because my GraphQL query is expecting to get an array of docking ports. So here I'll say DID or DID equals ID. Okay, awesome. So that's going to return an array of one item if we specify an ID. In most cases, we're not going to. So I'll say if simulator ID, in this case, I'll filter it by simulator ID, but I'm not going to return it right away because I also want to filter it by type if type is specified. So here I'll say docking ports equals docking ports.filter d.simulator ID equals simulator ID. Now remember, we didn't specify simulator ID over here because it's taken care of by our class that we're extending from. But that is one of the things that's required in order for this to work. Okay, now I do the same thing with type. If type docking ports equal docking ports.filter d.type equals type. Awesome. So that's that. Now we can return docking ports. That's all we have to do. So now our query is done. We don't have to do anything else with it. Let's worry about our subscription now. It's basically the same because it's going to return very similar data. So I copy that, paste it here, change it to docking update. Instead of getting it from the docking ports, though, I'm going to be getting this from the root value. So all that I have to do is just modify this to be root value. There's that. And then it's going to go through the exact same logic. I'm going to change it just a little bit so that it returns null if there are no docking ports. So I'll say docking ports.length. That means if the docking port's length, there's more than one item in the array, then return docking ports. And that just does a little short circuit, otherwise it returns undefined. Okay, awesome. So our query and our subscription is done. Now we have to do the mutation. Now, I realized I'm missing a mutation here because I have update docking port, but I don't have create docking port. So I'm going to come up here and say create docking port. And I can just use port docking port input, just like the other one. It's basically the same thing. I want to separate it though, just to make sure that we're perfectly clear on it. I should probably add one more, which is remove docking port. And in this case, it's just going to be an ID because I don't need any of the other information. So now I've got 3 mutations. So I'll copy all of these and I'll paste them into my resolver here. And they have exactly the same arguments: root value, params, and context, which I'm going to worry about now because context has additional information that we want. Okay, so in our app, we have a fancy method called handle event, which queues events for them to be triggered in our event sourcing system. So that's why I didn't split out the params, because I don't care about them right now. So app.handleEvent. The first argument is the params. The second argument is the name of the event. In this case, we'll name the event the same as the mutation to keep things simple. And then the third argument is context. Text. That just gets passed in so that it can have access to all of the necessary information that it needs to run properly. Okay, so with that, our resolver is done. We save the mutation. Now, finally, we need to make sure that we get our resolver inside of the index.js. So I'll come here, and you'll notice I'm exporting the queries, mutations, and subscriptions separate from each other, which is fine. It's the way that it is. So I'll come here and copy that, paste it here, change this to docking, and then change all three of these to docking. Make sure. Yep, I just called it docking. Awesome. So now I'll copy all of these and then do some fancy pasting on all three of these lines here. What these are is lists of all of the different queries and mutations and subscriptions. And what this does is it combines all of the resolvers together into one giant object. So we can have them split up, but then this combines them so that we can use them later on. Awesome. So now that that's taken care of, we can come back here. Thorium restarts. Looks like our resolvers are good. In fact, we can even go into graphical. So with it running, I can go to localhost 3001/graphical, just to make sure that we're clear on that URL, GRAPHIQL. And if I come here to the documentation explorer, I can type in docking, and I've got my docking types there, docking port input types. I've got my docking query, my three docking mutations, and then I have ship docking change, which doesn't matter. That's for the docking of the actual simulator. And then I have my subscription here. So we're all good. And then actually, if I run this, so if I do query docking and run it, it gives me an empty array. Perfect. That's exactly what it was supposed to do. So now that we have all that taken care of, I'm going to clean up just a little bit. We need to take care of our events. So we've got those 3 events that need to be created, and yeah, we're going to base those off of our mutations. So let me come here and load up my docking mutation file again so that I have it for reference, and then close that up, and open up events again. Create a new file called docking.js. One thing that I'll want to do before anything else is make sure that I have my docking class taken care of. So export docking from /docking. That's going to export my class so that I have access to it, which is great. And now I can come here to my events. Okay. And I'm actually going to copy crew here because it has all of the imports that I need. So I'll paste that in. Okay. So the way that this works is we put some event handlers onto the app, which I'm importing up here. And the event handlers we're going to put on are the events that we fire. So here are my 3 events. There are my 3 events. And actually what I'll do is I'll create 3 cursors like that and do app.on, the name of the event, and then a function. And that function takes the arguments of our mutations. So here in create docking port, it just has port. In update docking port, it just has port. And in remove docking port, it has ID, right? Nope, all 3 of them are port. That simplifies things. Okay, let's start with remove docking port. It's definitely the simplest. All that I have to do is just go app.dockingports equals app.dockingports.filter, and then I'm filtering it by the ID, which is port. So d.id does not equal port. In this case, if the ID does equal port, it's gone. It's not going to be included. So that filters it out. The second thing we have to do is publish our change, which triggers a subscription. So this is simple enough. I just say pub sub.publish. the name of the subscription, which in this case is docking update, and then whatever data I want to pass to the subscription resolver. In this case, it is the docking ports that we've just updated. So I'll just say app.dockingports, and that'll take care of that. Okay, and that's all that we need to do for remove docking ports. Next is going to be fairly simple as well. It's update docking ports. So here I need to get my port, const port equals update docking port. No, just kidding. That's wrong. And I actually have two ports here, so I need to do docking port so that I have different variable names. And here I'm going to do app.dockingports.find, and I'm going to find the individual class in there, and I'll use a couple of different methods. So I'm going to open this up so that it's there. Since port has a couple of ways that we can get our docking port, I'll check for all of them. If port.id, then return d.id equals port.id. Okay. If port.simulator ID, and actually I'm going to create a new variable here, at tf equal false. Okay, and then it's going to return tf at the end. So here, this allows me to create multiple checks. tf is going to equal port.simulator ID equals d.simulator ID. So if those are the same, then tf is going to become true. If those are different, then tf is going to become false. Actually, probably what I want to do is reverse that. Tf is true. Okay, so if that becomes false, then in the next one, which is checking for port.type equals d.type, and tf equals true, tf equals, oh, hang on. No, just kidding. If port.type. Yeah, okay, just like that. tf equals tf and port.type equals, oh, just kidding, d.type. Okay, so in this case, if tf is true, if tf is false, then it's just going to stay false. If tf is true, then it's going to check and see if port.type equals d.type, and if that's true, then it's going to return true. If that is false, then it's going to return false. If it returns false, then that's not the docking port we're looking for. If it returns true, then it is the docking port we're looking for. Great. So basically, this is going to just check and find the docking port that we're looking for so that we can do all of the stuff that we need to do on it, based on all of the parameters that we can search for. So now that we have our docking port, we can do docking port.update. Isn't that what I did? Let me go back to my class. Docking, update docking port. Simple enough. Update docking port, and we can just pass the port right into there, and then that's going to update it based on the data that we had in our class. And then I can use the same pub sub function to publish the change, and then everybody's going to get the change. I can put that up here too. Okay, let's create our docking port. This one's going to be really simple as well, actually. All we have to do is create a new docking port equals new classes.docking port. That's the correct class name. And then we put in our port as the parameters, and then app.dockingports.push docking port. That's all we have to do there. And there we go, we're done. Okay, that's how you create the backend system. Now, just to make sure that this all is working, let's do a couple of GraphQL mutations to check it and make sure that our backend is still running. It's running just fine. So query docking, and we've got docking, and that gives us the ID, and we can put in all of the other properties as well. ramps docked damage simulator ID. Awesome. And that's going to request a couple of extra things. Okay, good there. I'm not going to test subscriptions because that's a little tougher, but I'll create a mutation for create, and I'll create a mutation for update, and I'll create a mutation for delete. And this is a create docking port, and it takes a port which has a whole bunch of properties in it. And all of these basically take the same thing except this one. This is going to take a port which is a string, but I'll worry about that later. Oh, this is remove docking port. There. And then this is update docking port. Okay, so this is going to take a name, dist. It's going to take a type. We'll say this is a shuttle bay. It's going to take ramps. Well, and I suppose we don't have to include all of this. We only have to include the. So I can type docking types. Let's see. Shuttle bay. Yep. Maybe I need to change that so that it's a string. Let's see if that works. Let me put a simulator ID on here as well. Call that good. Create.